Okay, we're going to solve some polynomials using some factoring techniques. The first one is using greatest common factor. So let's look at example number 1. What is the GCF of these three terms? So we could pull out a 3 and an x. And then we're going to write down what's left on inside the parentheses. So 3x times what gives you 3x cubed? Well, x squared. And then 3x times something is going to give us negative 6x squared. So that would be a negative 2x. And then 3x times something is going to give us negative 9x. So that would be a minus 3. Then we're going to use the quadratic, solve the quadratic using some factoring techniques, or you can use the quadratic formula if you so desire. So I'm just going to bring down our 3x for the time being. And I believe this one is factorable. What's going to multiply to negative 3 and add up to be negative 2. So we could use a 3 and a 1, and one of those needs to be negative. So negative 3 times 1 is negative 3. Negative 3 plus 1 is negative 2. So we have x minus 3, x plus 1. Step 4, set each factor to 0 and solve. So we're going to have 3x is 0. X minus 3 is 0. And then x plus 1 is 0. So this would give us x is 0 as one solution. If I add 3 here, x would give me 3. And then if I subtract 1 from either side, here's our 3 solutions. Look at the degree of our polynomial. It was a cubic function, so we need to get 3 answers in there. They all are. Okay, example 2. Again, we're going to use step 1, GCF. If I look at all 3 terms, I could pull a 4 and an x out, greatest common factor. So 4x times what gives you 4x cubed? X squared. 4x times what gives you negative 8x squared? Negative 2x. 4x times what gives you a positive 4x? Well, I could multiply by 1 and get 4x. And then step 3, solve the quadratic using factoring techniques, or you could use the quadratic formula. So I'm going to go ahead and bring down my 4x, and then I'm going to attempt to factor what's in these parentheses here. So what multiplies to 1 and adds to get me negative 2? Negative 1 times negative 1 is positive 1. Negative 1 plus a negative 1 is negative 2. So we would have x minus 1. Step 4, take each factor and set it to 0 and solve. So 4x would equal 0. X minus 1 is 0. X minus 1 is 0. So x would be 0. Add 1 here. Alright, so we have x equals 0, x equals 1, x equals 1. Again, we had a degree of 3, so we have to get 3 solutions. Here they all 3 are. If you'll notice, x equals 1 is a multiplicity. So we have a multiplicity in this particular one. So we would have a bounce at 1 for our graph, and then it would go all the way through at 0. Alright, example 3. The GCF, we look at all 3 terms. We could pull out an x. And so x times what gives you x cubed? X times what gives you 3x squared? So that would give me 3x. X times what gives you 2x? Well, a 2. Take each of those and set it to 0. I'm sorry, first we got to factor this quadratic. So we need something that's going to multiply to 2 and add to be 3. It's like 2 times 1, give me 2. 2 plus 1 gives me 3. So we'd have x plus 2, x plus 1. Take each factor, set it to 0. So we have x equals 0, minus 2 from both sides here. Minus 1 from here. Okay, we can also factor trinomials if they are in quadratic form. And you'll notice it looks like something to the 4th, and then we go down to a square, and then we go down to nothing. So the exponents have to go 4, 2, nothing. So look at example 1. It goes 4, 2, and nothing. It's in what we would call, it's not quadratic, but it's in quadratic form. So we're going to use our factoring techniques. So I'm going to think about what would multiply to 9 and add up to be negative 10. So we're going to pretend for a moment that it is in fact quadratic, and we're going to use those same factoring techniques. So we could say 9 and 1. And we need to get a negative 10, which I don't think is going to. So we need to do maybe a negative 9 times a negative 1 to get positive 9. Negative 9 plus a negative 1 to get a negative 10. So we're going to write our factors as such. But remember, though, we're doing x to the 4th. So remember, x squared times x squared is x to the 4th. So instead of saying x here, we're going to say x squared minus 9, x squared minus 1. And we're going to take each factor and set those to 0. And I can factor this one a little bit further, or we could use the square root property. I think that's what I'm going to do here. So I'm going to add 9. So x squared would equal 9. And then if I were to take the square root of both sides, x would equal plus or minus 3. So I took each factor and I set to 0, and then I'm going to maybe use that square root property. Okay, we could do the same thing over here if I add 1. And then we're going to take the square root of both sides. So x would equal plus or minus 1. And notice that we had to get 4 answers. So I get plus 3, negative 3, plus 1, negative 1. I got all 4 of them. All right, look at example 2. In order to do this one, you have to have it set equal to 0 first. So we're going to have to add 16. And then solve. So I'm going to have you do that for your Google form. Okay, and then the last one that we're going to do this time is a difference of squares, which we've done when it was x squared, but now we could also have x to the 4th. So step 1, notice that we have 2 terms, a negative sign, and both terms are perfect. So we're going to factor. We're going to take the square root of each term. So the square root of x to the 4th would be x squared, and x squared like from the previous slide. And then 64, the square root of that is 8. One's plus and one's minus. Okay, step 3, we're going to factor any more if we can. 8 is no longer, it's not a perfect square, so we can't. So we're going to take each factor and set it to 0 and solve those individually. So I'm going to minus 8. And then I'm going to have to take that square root property. And we have a negative, so we know we're going to have an I. 8 is not perfect, so I'm going to break him down. So we're going to have 2i plus or minus, don't forget. Plus or minus 2i radical 2. And then on this one, I'm going to add 8. So x squared equals 8. Take the square root of both sides. x would equal plus or minus 2 radical 2. So we have 2 real solutions, and then over here we have 2 imaginary solutions. Notice that these come in conjugate pairs always. We had a degree of 4. We had to get 4 answers, and there they are. 2 of them are real, even though they're irrational, and 2 of them are imaginary because we have that I in there. Okay. Example 2, I'm going to have you do on your Google form. I'll see you in class. I hope you took some good notes.